Hello, my dear students. How are you? I hope that you will be very fine, and I am also very fine. Today, I am going to discuss usage of dimension. Now, I am going to discuss usage of dimension. First is in changing the unit of a physical quantity from one system to another system. How to change the unit of a physical quantity from one unit system to another unit system? Let us consider an example. Convert 1 Newton into dyne. Convert 1 Newton into dynes. Okay. Suppose 1 Newton is equal to x dyne. 1 Newton is equal to x dyne. This is unit and it is Newton. Newton means this will be force. Okay. Therefore, I write dimension of force, and left side, and on left side there will be SI unit, and right side there will be CGS unit. We have to find the value of x. How to find the value of x? For finding the value of x, this will be taken towards this. Okay? Therefore, x should be equal to m SI upon m CGS and L SI upon L CGS and T SI upon T CGS. Okay? Here this is mass. This is mass and SI unit of mass is 1 kg. You can convert both numerators and denominators in same units in SI or CGS. Now I am going to convert all the quantities into SI. Sorry, into CGS. This is SI unit 1 kg. 1 kg will be equal to 1000 gram. Therefore, I can write here 1000 gram and I can write here 1 gram. Okay? Similarly, 1 meter is equal to, this is SI unit. SI unit of length is meter. This is 1 meter means 100 centimeter and this is CGS unit of length. Therefore, I can write here 1 centimeter. Okay? In SI or CGS, time has same unit which is equal to second. 1 second divided by 1 second to the power minus 1. After solving this, we get 10 to the power 3 cross 10 to the power 2. This is 10 to the power 3, this is 10 to the power 2. This is x is equal to 10 to the power 5. Now, this value is putting in equation 1. Putting this value in equation 1, we get our result. 1 Newton should be equal to 10 to the power 5 dynes. You should remember this value 1 Newton is equal to 10 to the power 5 times. Just like 1 meter is equal to 100 centimeter. Okay. Now I am going to take second example question, which is shown here. Please look on the board. Here how to find 1 joule into ergs, how to convert, how to change 1 joule into ergs. Okay, let or suppose 1 joule is equal to x erg. On left side this is SI unit, on the right side this is CGS unit. Okay, value of x will be equal to m SI upon m CGS L SI upon L CGS to the power 2 T SI upon T CGS. Now I am going to put the value of all quantities into CGS. This is 1 kg, therefore this will be equal to 1000 gram. Here it is 1 meter and this will be equal to 100 centimeter. Okay, and this is second because unit of time in both CGS or SI are same. Okay, we know that any power of unity will be equal to unity. This value will be equal to 1, and this will be 10 to the power 3 and this will be 10 to the power 4 because this is square. Okay, therefore x should be equal to 10 to the power 7. Now putting this value in 1, we get 1 joule will be equal to 10 to the power 7 watts. So you should remember this value also, just like 1 Newton is equal to 10 to the power 5 times. Okay, here 1 joule is equal to 10 to the power 7 ergs. Erg is the CGS unit of work and joule is SI unit of work. You can solve this question by this method also. N1 E1 should be equal to N2 U2, where N represents number and U represents unit. You can write NE is equal to constant. Therefore, N inversely proportional to U. This means that greater the value of unit, greater the unit, a smaller will be value. Greater the unit, a smaller will be value, and vice versa. A smaller the unit, greater will be number. As for example, 1 Newton is equal to 10 to the power 5 dynes. This means that dyne is a smaller unit of force than Newton. Okay, dyne is a smaller unit of force, than Newton. Means Newton is larger unit, therefore dyne is a smaller unit. Dyne is a smaller unit. This is a smaller. Then this is a smaller, therefore this will be larger, and this value is equal to 10 to the power 5. 10 to the power 5 means 1 lakh. Now I am going to solve above question by this method. N1 U1 is equal to N2 U2. N1 is number on left side. Number on left side, and this is U1 unit, and this is N2 number, and this is unit U2. Okay. On the left side, this is SI unit and this is CJS unit. Therefore, we have to find the value of N2. Now, I am going to find N2. N2 will be equal to M1 by M2. This is 2 M1 by M2, L1 by L2 to the power 2, T1 by T2 to the power minus 2. Okay. Here 1 kg is equal to 1000 gram, and here 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter. After calculation, the value of N2 will be equal to what? 10 to the power 7. And now putting this value, 1 joule is equal to 10 to the power 7 hours. You can solve this question by this method also. Okay? In different books, this question is solved by this method also. Both are similar. Now I am going to tell you. Now I am going to discuss next use of dimension. Next use of dimension. This is not second, this is third. Sorry. This is second use. Okay. Now I am going to discuss second use of dimension. Checking the dimensional consistency of the equations. Any equation which is dimensionally consistent or not, you can check here. A formula or equation is said to be dimensionally consistent if all the terms of the formula or equations have same dimensions. Any equation or formula will be dimensionally consistent if and only if each term of the formula or equation has same dimension. Okay? Each term has same dimension. Check the formula or equation dimensionally consistent. I have written this point. This point is saying that a formula or equation is said to be dimensionally consistent if all the terms of formula or equations, all the terms of the formula or equation have same dimensions. You can also write, if any equation or formula is dimensionally consistent if and only if each term of the formula or equation has same dimension. Okay? Now I am going to give you example question. Check the formula or equation dimensionally consistent. Whether the equation or formula dimensionally consistent or not. Dimensionally consistent or not. V is equal to U plus AT. here this is where symbols have their usual meanings. This means u is initial velocity, v is final velocity, a is acceleration, t is time. Okay, as their usual meanings. V is equal to u plus at. This formula is consistent or not? This formula is physically correct or not? First of all, I am going to check. Consistent or inconsistent. Any formula will be dimensionally consistent if each term of the formula or equation has same dimension. Okay, this equation has three terms, 1, 2, 3. Okay, therefore all terms have same dimensions. Dimension of v will be equal to Lt minus 1 because this is velocity, final velocity. This is initial velocity. Any velocity, dimension of any velocity will be same. Dimension of u will be equal to Lt minus 1. Dimension of at will be equal to Lt minus 2. And dimension of t is t. This is dimension of acceleration and this is dimension of time. After calculation, this will be equal to Lt minus 1. Okay. Now I am going to see here. I am observing that on right side all are equal. Therefore, I can say that each term of this equation has same dimension. Therefore, each term has same dimension. Therefore, the given equation or formula will be dimensionally consistent, but it will be also physically correct. This will be also physically correct. Okay, because this formula is used in physics, therefore it is physically correct also. Now I am going to check this equation. In similar way, you can check here. First of all, I am observing that how many terms in this equation? There will be three terms. This is first term, second term, and this is third term. Any equation will be dimensionally consistent if each term has same dimension. Okay. Now I am going to find dimension of each term in this equation. First of all, I am going to find the dimension of this term. This will be equal to Lt minus 1 because this is final velocity. Okay. Now I am going to find dimension of this quantity. This quantity is 2u. 2 is number. We know that dimension of any number 1, 2, 3, 4 will be equal to unity. Unity means powers of fundamental quantity. Powers of fundamental quantities present will be equal to 0. We know that if power is 0, then the value will be equal to 1. Now I am going to discuss the dimension of 2. 2 is a number, therefore dimension of 2 is 1. Okay. U is initial velocity, therefore it will be equal to Lt minus 1 and this will be equal to Lt minus 1. Now I am going to find dimension of third term. This term has constant 3, this is number, therefore it has dimension 1. Okay, and this is acceleration, dimension of acceleration is LT minus 2. This is time and dimension of time is t. After calculation we get this result. Okay, LT minus 1. Here you see that on right side all terms are same. Okay na? Okay, therefore all the quantities on left sides will be equal to each other, therefore V should be equal to this and this. Here I am observing that all the terms of this equation have same dimension, therefore I can say that this equation is dimensionally consistent. The given equation or formula will be dimensionally consistent, but you cannot study this formula in physics. Therefore this it is not physically correct. Okay, this equation, this formula is not physically correct. Okay, this formula is not physically correct. Okay na? This formula is not physically correct, but this equation or formula will be dimensionally correct because each term of the formula has same dimension. Okay, now I am going to give homework HW. This is HW. An object accelerates uniformly from initial velocity u to final velocity v. It travels distances in time t. Then check the dimensional consistency of the following equations. Which of them are correct physically? Okay, I am going to solve first question. V average will be equal to u plus v by 2. You can write this formula in this form. Okay, u upon 2 plus v upon 2. Here in this equation there are three terms. This is first term, and this is second term, and this is third term. Each term has same dimension, then formula will be dimensionally consistent or not. Okay, first of all I am going to check each term has same dimension or not. Dimension of the average velocity, v average, this is velocity, therefore dimension of average velocity will be equal to the dimension of velocity. Okay, LT minus 1 and u upon 2. Here this can be equal to, this will be equal to half into u. Half is number, therefore its dimension is 1, and u is initial velocity, therefore its dimension is LT minus 1. Okay, 1 into LT minus 1 will be equal to LT minus 1. Here v upon 2, this can be written as this, half into v, therefore half is a number. Dimension of any number will be equal to unity, therefore I can write here 1 and here LT minus 1. After multiplication, this will be equal to LT minus 1. Okay. Here I am observing that dimension of this will be equal to dimension of this. Therefore, given formula or equation will be consistent and physically correct also. And physically correct also. Physically correct also. Okay? Because you can, because you will study average velocity. This is also called as mean velocity. Will be equal to u plus v by 2. Okay? Now I am going to give you these two questions as your homework. Okay? These two questions, this is dimensionally correct, consistent, and this also will be physically correct, because you will study this formula in physics, but this is not physically, this is not dimensionally consistent, or it is not physically correct. If any formula or equation is dimensionally incorrect, or you can say that if any formula or equation is not consistent, then it will be always, it will not be physically correct. Okay, it will not be physically correct. If a formula or equation is dimensionally incorrect, then it will not be physically correct. Okay. Now I am going to end the class. Have a nice day. Namaskar from my side. See you again tomorrow.